So, physics lesson 3.1, part 4. This is going to be a very short lesson, essentially just focusing on filling out page 158. So, concept number 4, physical quantities contribute to different forms of energy. And this is page 209, I believe, in the textbook, 158 in your notes. So, different physical quantities can be measured, such as mass and speed. And these contribute to different forms of energy. So things we can measure from an object, mass, speed, volume, general size, density, etc., we can physically measure and physically calculate that aren't necessarily like temperature that you can measure, which is specifically measuring the type of energy. So when we measure temperature, we are measuring a type of energy. For these other measurements, like mass, etc., these are physical quantities that we are measuring. So things that we do not necessarily attribute to energy are these physical qualities, but they can still contribute to different forms of energy. So they may not pop into your head as the first example of energy, but they do contribute to different forms of energy. So for example, the speed and weight of a ball will determine if it will knock over a target. This means both mass and speed contribute to the mechanical kinetic energy of the system. So if you throw a ping pong ball really gently at something, or throw a bowling ball really hard at something, it's going to change whether or not there is enough energy that can be transferred when the ball hits whatever object in order for the object to actually move. So essentially, in order to have enough mechanical kinetic energy transferred to it, referring to the second object, in order to see it actually move visibly, would be a visible result of the transfer. Second example, the Earth's gravity, the mass and the height from which an object falls, contributes to its gravitational potential energy. So potential energy is sort of like the buildup for our kinetic energy. If we go to a different planet, for example, the moon, or different planet or the moon, because the moon isn't a planet, where the gravity is different, then the gravitational potential energy is going to change accordingly. So the height from which an object falls impacts this as well. So the higher up I hold something, the more potential energy it therefore has. And then that gets converted into kinetic energy, which means the more impact it's going to make. So if I hold something really high, it's going to therefore have more potential energy, which then gets converted into kinetic energy, which then has an impact. This is the same thing with mass. If I hold a feather above your foot versus a bowling ball, it's going to feel a lot different when it hits you. Same height, same gravity, but the mass will contribute to the potential energy, so that's stored energy, which then in turn contributes to the kinetic energy that you end up feeling. Okay, so visualizing physical quantities that affect kinetic and potential energy. So this is page 210 to 211 in your textbook. So there's a diagram of a person sliding on a sled. Textbook, again, is uploaded onto files, so you can see that at home. So for each stage of the slide, you are going to describe the gravitational potential energy, abbreviated as GPE, so you can see here, and the mechanical kinetic energy, which is abbreviated as MKE. And then you're going to draw a pie chart representing kind of the proportion of kinetic to potential energy. Something to note here, there is a small error. One, this should not say not, it should say no KE, but these descriptions are actually switched. So please make sure these are switched in your notes, or that you have an arrow saying that these are switched. So this one is actually referring to potential energy, and the other one is referring to kinetic energy. If we're looking at the gravitational potential energy at the start point, so I'm just reading point 1, the sled is sitting on the highest hill. So at that point, the sled is at the greatest height, so it will have maximum potential energy. So basically it has 100% potential energy. The kinetic energy at this point is because the sled is not moving, so it has no kinetic energy. So again, 100% potential energy, no kinetic. So go through and look at each of these examples and determine the relationship between GPE and MKE. So essentially you're describing what's happening for both of these energies, and then you're drawing it in the pie chart. So you're completing the rest of this slide. So you can pause here if you need to, but this is in your notes as well. And then there are a few more questions for you to answer, but that is it for this part of our physics lesson.